You were introduced to vectors, the definition of vectors, on the activity that you did last Thursday. And you saw some of the applications and ways that they can be used to combine forces or movement, and usually those are physics applications. We're going to talk a little more specifically about vectors over the next couple days. And there's a couple different ways that we can define vectors. A geometric vector is a directed line segment from one point to a second point. It has a magnitude, which is the length of the directed segment, and a direction from the initial point to the terminal point. Every vector is drawn with an arrow at the end to show that it has a starting and ending point. It shows which direction the vector goes in. You don't have a vector if you don't have an arrow. Geometric vectors are really what you were working with in the activity on Thursday. What we're going to do today is continue with that idea, only we're going to start adding and subtracting and multiplying by a number with these vectors. And we can do that geometrically. So here I have a vector u, a vector v, and a vector w. And again, when they're typed, we type the vectors in bold. But if you're handwriting a vector, I would write u with a one-sided arrow above it and v with a one-sided arrow. That's the notation that tells me this is vector u plus vector v. And you can't handwrite in bold, so you use the arrow. So here, if we want to add u plus v, we're going to add them head to tail like you did in the activity the other day. But you'll notice in this case, these are just free floating vectors. A vector is not identified by where it starts, it's identified by the magnitude and direction. So vector u is the same vector no matter where I put it. It's always this vector that has this length and is going up and to the right at whatever that angle that is. So if I want to add u plus v, and I'm going to do it in the head to tail method, I draw u, and then I draw vector v, grab this, and I put the head of vector v at the tail of vector u. This is u, this is v. Now, I'm not done until I have my resultant drawn. My resultant is the vector that starts at the initial point of the first vector and ends at the terminal point of the second one. And again, it's not a vector until I put an arrow there. So I'm starting here and ending there, so I need the arrowhead to go this way. You need to make sure that when you do these problems, you label your resultant vector, the sum, and that you show an arrowhead to show which direction it goes in. I can add two vectors, u plus v. I can also multiply in this way, and when we say multiply, this is called a scalar multiple, a number times a vector. I'm going to make 3 times vector u, which means I'm going to take vector u and add it head to tail 3 times. This final vector is my product 3 times the vector u. Another thing we want to introduce here is a negative vector. So negative v. V is the vector that goes down and to the right with this magnitude. Negative v is going to go in the exact opposite direction. It has the same magnitude, but goes in the opposite direction. So we're going to change where the initial and terminal points are. A negative vector has the same magnitude, but the opposite direction. Now, usually what we do is we take these vectors and we put them onto a grid. Not a coordinate plane necessarily, but we have a grid where, for example, I can see that this vector u is going up 2 and to the right 2, so that when I draw it, it's always the same length. For tonight's homework, I've attached a piece of printable graph paper, if that's helpful for you to print so that you can draw. There's a few of these that you need to draw. You can draw them on graph paper to show that you have the exact sum. So here, if we want to add these on the grid, I can see u. I'm going to start this where I know I have enough room. There's u plus v. And then I'm going to draw my resultant. My answer is this vector that goes straight to the right. It's a horizontal vector here that has u plus v as its resultant. If I want to do v minus u, I would start with vector v, And then u goes up 2 and right 2, so negative u is going to go down 2 and left 2. So this is negative u here. I had v, this is negative u, and then my resultant is going to go from my first point down to where I ended. This is the resultant v minus u. And we can add vectors. This is 2v plus 3w, and I'm going to need some more room to do this, so I'm going to bring v down here, another v down here. I'm going to do this down below, and then 3w. So I need to add these head to tail. I'm going to do v plus v, and then I'm going to add 3w to that. So w, add w to the end of that. This is going to go a little off my page here. And w to the end of that. And what we want is our resultant, which is going to go from the first point all the way down to where the last one ends. Unfortunately, it is too big for this screen when I'm not projecting on a smart board. So there's my 2u or 2v plus 3w. It's that long one. And you're doing this homework, just a warning, make sure you kind of start in a place of graph paper where you know that you can go in the right direction and length that you want to. Just real quick, couple properties of vector addition. Here I have vector u and vector v. If I add u plus v, I'm going to leave u here. U goes, I'm going to use the red lines, goes up 1 over 2, up 1 and over 2, there's u, and then v goes down 3 and right 1, 2, 3, and 1. When I add those, my resultant u plus v is a vector that goes down 2 and right 3. If I add them in the other order, I start with v, so I start by going down, if I start here, I go down 3 and right 1. There's v, and then I add u, which goes up 1 and over 2, up 1 over 2. What I should see is that the resultant vector goes down 2 and right 3. The resultant vector is exactly the same. Vector addition is commutative. The order can change and you will still get the same answer. It doesn't matter which way that you order things in. And if you think about the problems you were doing the other day, if you're talking about two forces, if they're both pushing on an object, it shouldn't matter which one you start with. If they're both pushing at the same time, the resultant should be the same time, should be the same amount. Here, I'm going to add v plus w. So w was on the previous page. V was on the previous page. V went down 3 and over 1. V went down 3 and over 1. Here's v. And then I add w to it. W goes over 3 of these red marks. 1, 2, 3. Here's v plus w, the vector that starts here and goes down to there. So v plus w is a vector that goes down 3 and then right 1, 2, 3, 4. Now I'm going to add vector u plus that sum. So I'm going to use the sum in this work. U was the vector that went up 1 and right 2. So I'm going to take u, I'm going to go up 1 and right 2. And then I'm going to add to that my resultant from here that goes down 3 and right 4. 1, 2, 3, 1, 2, 3, 4. I would end up here. So there's u plus the sum v plus w. And my final answer is the vector. I'm going to draw using the line tool here to make it a little better. My final answer is this vector, which if we look at this one, goes down 2 and goes right 1, 2, 3, 4, 5, 6. Here I'm going to add in the other order. I'm going to add the u plus v first, which we have up here. U plus v is the vector that goes down 2 and right 3. I'm going to start with that. I'm going to go down 2 and right 3. And then to that, I'm going to add w. W goes right 3. 1, 2, 3. And my final result in here, from the initial point to the terminal point, put the arrowhead on it, always, 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 goes down 2 and goes right 1, 2, 3, 4, 5, 6. It's the same vector. So it's down 2 and right 6, which is the same for both. So that means that vector addition is also associative. You can add 2 vectors first and then add them to the third one. It doesn't matter which 2 that you start with. These are properties that we know work for numbers, but they also work for vectors. So today's homework is doing some geometric addition, subtraction, multiplication by a scalar, and then working with these geometric vectors.